Hello everyone. Today we are going to analyze a fixed beam when it carries an eccentric couple. You can see that the couple M is acting in the clockwise direction. It is acting in the point C, which is at the distance of A from the left side. In this analysis, we are going to find out the fixed end moments, the reactions. Also, we are going to find out the deflection and slope under the couple and maximum deflection in AC and CB. To find the fixed end moments, we are going to use Mohs theorems. First, let us use Mohs' first theorem. It states that difference of slope between A and B will be equal to area of moment upon EI diagram. Let us apply this theorem in this fixed beam. The difference of slope between A and B is theta A minus theta B. In this beam, in the point A, there is a fixed support. In the fixed support, there will be no slope. So, theta A will be 0. In the point B also, there is a fixed support. So, theta B also will be 0. 0 minus 0, we will get 0. So, using the Mohs first theorem, we have formed one equation. Area of moment diagram upon EI will be 0. Now let us find the area of the moment diagram. We are going to find the moment in the point A from the point B. In this case, we are moving towards left hand side. Clockwise will be negative and anti-clockwise will be positive. Let us take the fixed support in the point B. In the fixed supports, there will be a vertical reaction here, that is RB, and there will be a fixed end moment here, that is MB. Let us assume that RB is acting upwards and MB is acting in the clockwise direction. We have to make the bending moment diagrams separately. Up to the point A, there are three forces: the couple M, the vertical reaction RB, and the fixed end moment MB. Now let us find the moment in the point A due to RB. RB is acting towards the point A in the anti-clockwise direction, so it will be positive and the distance is L. So the moment is RB into L. Since the moment is positive, the diagram will be positive. In the point B, there will be no distance. So here the moment will be 0 and here the moment will be RBL. Using these values, we can make this diagram. So due to RB, we got a triangular bending moment diagram. Now let us make the bending moment diagram due to MB. MB is a moment. The moment will never change. It will be same from the point B and up to the point A. In this case, we will get a rectangle shaped diagram. MB is acting in the clockwise direction, so the moment will be negative. Now let us make the bending moment diagram due to the couple M. The couple M also will not change. From the point C up to the point A, it will be M. So here also we will get a rectangle shaped diagram. The couple M is acting in the clockwise direction, so the moment will be negative. Let us name this diagram as 1 and this diagram as 2 and finally this diagram as 3. Now let us find area 1. This is a triangle. We know the formula for the area of a triangle: half into breadth into height. Here the height is RBL and the breadth is L. Using the formula, we are getting the area 1 RBL square upon 2. Now let us find area 2. This is a rectangle. When we multiply MB with L, we will get area 2. Since the moment diagram is negative, we have to apply a negative sign with the area. Now let us find area 3. This is also a rectangle. When we multiply M with A, we will get the area. Since the moment diagram is negative, we have to apply a negative sign with the area. We know that area upon EI is 0, but we have separated the area into 3 parts: area 1, area 2 and area 3. Let us take EI outside and take it on the right side. EI into 0, we will get 0. Then let us apply the area values. Let us take these two terms on the right side, so they will become positive. Then let us take L square upon 2 on the right side. It will come inversely. Let us keep this equation as number 1. Now let us use Moore's second theorem. It states that vertical intercept of AB is equal to area of moment upon EI diagram into distance from A to centroid of moment upon EI diagram. The vertical intercept of AB is the tangent A upon B. Let us keep the area of moment upon EI diagram as A, same like in the previous step. Let us keep the distance from A to centroid of moment upon EI diagram as x bar. Now let us apply this theorem in this fixed beam. In this beam, in the points A and B, there are fixed supports. In the fixed supports, there will be no slope and deflection. So the tangent A upon B is 0. You can see that the elastic curve does not start in the point A. It starts after some distance. You can see that there is a gap. Also, it ends before the point B. You can see that here there is a gap. So the tangent A upon B will be 0. So using the Moore's second theorem, we have made an equation Ax bar upon EI is 0. In this equation, now let us find Ax bar. We have already found area 1, area 2 and area 3. So now we have to only find x bar 1, x bar 2 and x bar 3. We know that x bar is the centroid distance towards the point A. First let us find x bar 1. This is a triangle. The centroid distance towards this height is L into 1 upon 3. We will get L upon 3. Let us apply this value here. Now let us find x bar 2. This is a rectangle. For the rectangle, the centroid lies in the center. So we can easily find the centroid distance towards the point A. For that we have to divide the length by 2. So the centroid distance is L upon 2. Let us apply that. Now let us find x bar 3. This is also a rectangle. So we can easily find the centroid distance. This length is A. When we divide A by 2, we will get the centroid distance. Let us apply that here. Now let us multiply the area with the centroid distances. When we multiply area 1 with the x bar 1, we are getting RB L cube upon 6. When we multiply area 2 with the x bar 2, we are getting minus MB L square upon 2. When we multiply area 3 with the x bar 3, we are getting minus MA square upon 2. We know that area x bar upon EA is 0, but we have separated area x bar into 3 parts, so we have to add them. EA is common. Let us take it outside and take on the right side. EA into 0, we will get 0. Now let us apply area x bar values. Let us take these two terms on the right side. They will become positive. Then let us take this 2 outside. Also let us take this 6 on the right side. So it will come in the numerator. Here instead of RB, let us apply this value which we got from the equation number 1. We can eliminate this 2. Here it will be 3. Let us eliminate this L square and cube. Then let us multiply these with 2L so that we will get these, and let us multiply these with 3 so that we will get these. Then let us rearrange the terms like this. 3MBL square minus 2MBL square, we will get MBL square. From here we can take MA outside. Let us take L square and the other side, so it will come in the denominator. We know that L is A plus B. Let us multiply 2 with A plus B. When we do that, we are getting this. 2A minus 3A, we will get minus A. Finally, we have made a formula for MB. MA upon L square into 2B minus A. We have made an equation for RB, that is the first equation. In the first equation, let us apply the value of MB. We can eliminate L and square, and let us take MA outside. Here let us take LCM. Let us keep L as LCM. So we have to multiply 1 with L. L into L square, we will get L cube. Instead of L, we can apply A plus B. Minus A plus A will be eliminated. 2B plus B, we will get 3B. 2 into 3, we will get 6. Finally, we have made a formula for RB, 6MAB upon L cube. Now we are going to find out RA. For that, I am going to apply the rule sigma V is equal to 0. RB is acting upwards, so it will be positive. Let us assume that RA is also acting upwards, so it also will be positive. But for RA, we will get a negative value. That means our assumption is incorrect. We assumed that RA is acting upwards. Since we got a negative value, RA is actually acting downwards. Now we are going to find MA. Let us assume that MA is acting in the clockwise direction. To find out MA, I am going to take moment about A from the point B. In this case, I am moving towards left hand side. Clockwise will be negative and anti-clockwise will be positive. MB is acting in the clockwise direction, so it will be negative. RB is acting towards the point A in the anti-clockwise direction, so it will be positive, and the distance is L. The couple moment is acting in the clockwise direction, so it will be negative, and MA is also acting in the clockwise direction, so it also will be negative. We can eliminate this L. Here it will be square. Then let us take minus MA on the other side, so it will become positive. Let us multiply 2b minus a with this. When we do that, we will get these. Then let us add these two terms. When we do that, we will get these. Then let us take LCM. Let us keep L square as the LCM. So we have to multiply m with the L square. Let us take m and L square outside. Here instead of L, let us apply a plus b. For a plus b the whole square, let us apply the formula a square plus 2ab plus b square, then multiply with the negative sign, so we will get negative values. Then let us eliminate a square and minus a square. 4ab minus 2ab, we will get 2ab. From here, let us take b outside. Finally, we have made a formula for MA, MB by L square into 2A minus B. In this analysis, we have made the formulas for the fixed end moments MA and MB. We assumed that MA is acting in the clockwise direction. Also, MB is acting in the clockwise direction. These are only the assumptions. The direction of MA and MB will depend on the distances A and B. So MA will be either clockwise or anti-clockwise. Also MB will be either clockwise or anti-clockwise. In this analysis, let us keep this way. MA is acting in the clockwise direction and MB is also acting in the clockwise direction. In this beam, in the points A and B, there are fixed supports. In the fixed supports, there will be no slope. So theta A and theta B will be 0. Also, in the fixed supports, there will be no deflection. So the deflection in the point A and in the point B will be 0. Now we are going to find the deflection and slope in the point C. For that we are going to use double integration method. Let us make a section XX between A and C at the distance of X from the point A. In this section we are going to find the moment from the point A. In this case, we are moving towards right hand side. Clockwise will be positive and anti-clockwise will be negative. MA is acting in the clockwise direction, so it will be positive. RA is acting in the anti-clockwise direction, so it will be negative, and the distance is x. Let us equate mxx with the EA d square y upon dx square. Let us integrate this equation on both the sides. When we integrate ei d square y upon dx square, we will get ei dy upon dx. For integrating these, let us use this formula. Using the formula, we are getting this. C1 is the constant. We can eliminate this 2. Here it will be 3. Let us integrate this equation again. When we integrate ei dy upon dx, we will get eiy. For integrating these, we can use the formula. After integrating, we are getting this. We can eliminate this 3 and this 3. So we will get this. We can multiply 2 with L square. We know that dy upon dx is the slope. In the point A, there is a fixed support. In the fixed support, there will be no slope. So when x is 0, dy upon dx is 0. In this equation, let us apply x is 0 and dy upon dx is 0. When we do that, we are getting C1, which is 0. Also, we know that in the fixed support, there will be no deflection. So, when x is 0, y will be 0. In this equation, let us apply C1 is 0, x is 0 and y is 0. When we do that, we are getting C2, which is also 0. In the ei dy upon dx equation, let us apply the value of C1. After that, we will get this. This is the equation for the slope. Let us keep this equation as number 2. Let us apply the values of C1 and C2 in this equation. When we do that, we are getting this. This is the equation for the deflection. Let us keep this equation as number 3. Now we are going to find the slope under the coupled moment. So we have to find the slope in the point C. For that, in this equation, instead of x, we have to apply a. You can see that instead of x, I have applied a. From here, let us take MAB upon L square outside. Then here, let us take LCM. Let us keep L as the LCM. L into L square, we will get L cube. Instead of L, let us apply A plus B. Then let us multiply 2A with A plus B. We will get this. And B with A plus B, we will get this. 2A square minus 3A square, we will get minus A square. 2AB minus AB, we will get AB. Then let us take negative sign on the outside. So here we will get A square plus B square minus AB. Then let us take EI on the right side. It will come in the denominator. This is the formula for the slope in the point C. Now let us find the deflection in the point C. For that, in this equation, instead of x, we have to apply a. You can see that in this equation, instead of x, I have applied a. From here, let us take MB A square upon L square outside. Here we can take LCM. Let us keep 2L as common. So we have to multiply these two values with the L on the numerator and denominator. We have to multiply this term with 2 on the numerator and denominator. So we will get this 2L into L square. We will get 2L cube. Instead of L, let us apply A plus B. Let us multiply 2A with A plus B. We will get this. and let us multiply minus b with the a plus b. We will get these. We can eliminate 2a square and minus 2a square. 2ab minus ab, we will get ab. From here, let us take b outside. Let us take ei on the right side, so it will come in the denominator. This is the formula for the deflection in the point C. Now we are going to find the maximum deflection for AC. We know that when the deflection is maximum, the slope will be 0. We have already formed the slope equation, which is the second equation. In this equation, let us apply the slope dy upon dx is 0. Now we have to find the value of x. From here, let us take mbx upon L square outside. Then take this on the right side. So we will get 0. Let us take minus 3ax upon L on the other side. So it will become positive. Let us take 3a upon L on the right side. So it will come inversely. Finally, we have made a formula for x. In the deflection equation, instead of x, let us apply these. L into 2a minus b the whole square, we will get L square into 2a minus b the whole square. 3a the whole square, we will get 9a square. L into 2a minus b the whole cube, we will get L cube into 2a minus b the whole cube. 3a whole cube, we will get 27a cube. We can eliminate L square. 2 into 9a square, we will get 18a square. Then let us multiply these two. We will get 2a minus b the whole cube. Let us eliminate L cube and a. Here it will be square. Then let us take mb, 2a minus b the whole cube and 9a square outside. Here we will have 1 upon 2 minus 1 upon 3. Here we can take LCM. 3 minus 2 we will get 1. 9 into 6 we will get 54. Let us take EI on the right side. It will come in the denominator. This is the maximum deflection for AC. Now we are going to find the maximum deflection in CB. For that, I have made a section XX at a distance of x from the point B. Now I am going to find the moment about the section MXX from the point B. In this case, I am moving towards left hand side. Clockwise will be negative and anti-clockwise will be positive. MB is acting in the clockwise direction, so it will be negative. RB is acting in the anti-clockwise direction, so it will be positive and the distance is x. Let us equate mxx with ei d square y upon dx square. Let us integrate this equation. After the integration, we will get this. Let us integrate this equation again. After the integration, we will get this. In the point B, there is a fixed support. In the fixed support, there will be no slope. So when x is 0, dy upon dx is 0. Using these, we can get C1. In the fixed support, there will be no deflection. So when x is 0, y will be 0. Using these, we can find C2. In the ei dy upon dx equation, let us apply the value of C1. This is the slope equation. Let us keep this equation as number 5. In the EIY equation, let us apply the values of C1 and C2. When we do that, we are getting these. This is the deflection equation. Let us keep this equation as number 6. Now we are going to find out the maximum deflection. We know that for maximum deflection, the slope will be 0. So in this equation, let us apply dy upon dx is 0 and find out x. From here, let us take minus max upon L square outside and take it on the right side. So we will get 0. Let us take minus 3bx upon L on the other side. So it will become positive. Finally, we are getting x, which is equal to L into 2b minus a upon 3b. In the deflection equation, let us apply the value of x. L into 2b minus a the whole square, we will get L square into 2b minus a the whole square. 3b the whole square, we will get 9b square. L into 2b minus a the whole cube, we will get L cube into 2b minus a the whole cube. 3b the whole cube, we will get 27b cube. Let us eliminate L square. 2b minus a into 2b minus a the whole square, we will get 2b minus a the whole cube. Let us eliminate L cube. Also, let us eliminate b. Here it will be square. From here, let us take minus ma 2b minus a the whole cube upon 9a square outside. Here, let us take LCM. 2 into 3, we will get 6. Here, we will have 3 minus 2. 3 minus 2, we will have 1. 6 into 9, we will have 54. Let us take EI on the right side. It will come in the denominator. This is the formula for the maximum deflection for CB. We have found the maximum deflection for BC. It occurs at the distance of L into 2b minus a upon 3b from B. So this distance is from the point B, but it will be more convenient if we have the distance from the point A. To get the distance from the point A, we have to subtract this by L. Here, let us take LCM. So we have to multiply L with 3b. So we will get 3bl. Let us multiply L with these. So we will get these. 3bl minus 2bl, we will get bl. Then from here we can take L outside. B plus A is L. L into L, we will get L square. So the maximum deflection for BC occurs at the distance of L square upon 3b from A. So for AC, the maximum deflection occurs at L into 2a minus b upon 3a from the point A. This is the formula for the maximum deflection. For CB, the maximum deflection occurs at the distance of L square upon 3b from A. This is the formula for the maximum deflection. Now let us consider the whole span AB. Here let us see where the maximum deflection occurs. The maximum deflection occurs in CB because B is greater than A. We already know the formula for the maximum deflection in CB. It occurs at a distance of L square upon 3b from A. Now we are going to end this session. Thank you for watching this video.